Testing, here we go. We're a little bit pressed for time. I started this yesterday, but I ran into a small problem and I couldn't continue. So here we are back today, which is Tuesday. So I'll go back over this rather than erase it and start over, because I have a Zoom call coming up in about an hour and 15 minutes. So I have quadratic expressions and equations. November 9th, of course, this is November 10th. So what I started with yesterday is first giving you the basic understanding of how a quadratic expression is written. So the standard form will be ax squared bx plus c, where a is the coefficient of the squared term, b is the coefficient of the single variable without a square, so it's actually at the first, the exponent is 1, and c is the constant. That will make sense as we come back to it. So the one we've talked about already in dealing with quadratic equations or expressions, but it's only makes sense when it's an equation. So if you don't have an equal sign, there's really no practical purpose for working something out. So this is a quadratic expression without the equal 0, and it is equation when you add the 0. So the first thing we did, or first thing you can see here, if we applied this standard form, you would see that in the equation we have here, a is 1, b is 5, and c, the constant, is 6, is no variable. So we started off saying the other day, last week now, to work with quadratic formulas or expressions, you try to factor them. So since there's no coefficient here, really there's a coefficient of 1, but there's no coefficient higher than 1. So we know our two factors of x squared is x and x. So if I think reverse of my distributive property, x, this first term times this first term makes this first term. This first term times this second term, and then this second term times this first term is where the middle term comes from. So I have to think of two factors that will make x squared. That's x and x, so that's easy. Then I look at my signs, because the signs are like signs on a highway or street signs. They tell you things. The last sign is the first one I look at, because it tells me whether or not these two signs are the same or they're different. In this case, I know they're the same because the only way you can end up with a positive is to either have two negatives or two positives. So once I know they're the same, I go to the preceding sign, and it tells me that in this case, they're both positive. If this was positive and this was negative, I would know that the two signs are negative. So that's how I would do it. So I have two factors now. The quantity x plus 3 is factor 1. Quantity x plus 2 is factor 2. They both equal 0. The product is 0. So the rule that you're applying is if the product of two factors is 0, one of them have to be 0. Because the only time the product can be 0 is one of the two factors is 0 itself, because 0 times anything is 0. So you simply set this equal to 0. X plus 3 equals 0, or x plus 2 equals 0. One of them have to be 0. If it's the first one, x equals negative 3. You subtract 3 and you only have x left. If it's the second one, x plus 2 equals 0, and then x equals negative 2. So the fact that this is a square tells you that there's two answers. So here's the two answers, negative 3 and negative 2. So there you go. That's the factoring option. That's why I have option 1 is factoring. Now there are cases, and there's a lot of them, where you can't factor into two terms like this because there simply are no numbers. Let's say if this was a 5, there's no two numbers that multiply to make 5 and add to make 5. 5 and 1 makes 5, but 5 and 1 makes 6 too. So, and the only factors that will make 5 are 5 and 1, or 1 and 5, but they won't make this 5. So you'd have a situation, if this were 5, you have something that you can't factor. So if you can't factor it, there's a second option of solving the quadratic formula. It's called completing the square. So that's what we will do now. I'll show you how you would complete the square. Now it's a fairly simple theory, but it takes a little patience to make it work. So let's use the same formula here, same equation here. X squared plus 5x plus 6 equals 0. Now we know that this can be factored, so we're going to use it as a way to check our work here too. So you'll see how it goes. So completing the square is really referring to a process where you're going to make a perfect square. And what does that mean, a perfect square? Like a perfect square would be x plus 2 times x plus 2. Because the two terms are the same, so they're both equivalent, and we say when you multiply them, you get a perfect square. So if we multiply this out, we get x squared plus 2x plus 2x will be 4x plus 4. So that's a perfect square, because when I find the square root of it, I get the same number. Like we say 16 is a perfect square because it's 4 squared. Both factors are 4. 9 is a perfect square because that's 3 squared. 4 is a perfect square, that's 2 squared. So you get the idea. So we can figure out what would be the perfect square here. So what we have to do, our first step, is we move our constant term. So we'll take that to the other side. So that leaves us with x squared. Now, talking about patience, I have to really be patient because I don't like the markers that don't make this clear for you. So x squared plus 5x, and once I move the 6, I have a negative 6 on the other side. So I'm ready so that's my step 1. Step 1, I'm going to say step 1 is move the constant, c. Step 2 is to take half of the coefficient of the x term. So I have x squared plus 5, plus 5x plus 5 over 2. Because half of 5 is 5 divided by 2. So if I take half of b and then I square it, that will create a perfect square right here. So let's do it and we'll see. So if I have, now since I've added 5 over 2 squared, I have to add it to this side, otherwise it won't be equal. So that's negative 6 plus 5 over 2 squared. So let's go through. So step 3 now is to work this out. So x squared plus 5x plus 25 over 4. You follow that? 5 halves squared is 5 times 5 and 2 times 2. Or if you wrote it out all the way, it would say 5 over 2 times 5 over 2. and you can see you're just multiplying across. You get 25 over 4. So I have 25 over 4 equals negative 6 plus 25 over 4. Are we making sense to you right now? So what we will do now, we're trying to see if we can come up with these responses once we complete the square. So now I could factor this, because now it's a perfect square. So I get x plus something, x plus something. So x plus 5 over 2, x plus 5 over 2. Does that make sense? Because if I have, let's see if it does make sense. X times x is x squared. 5 over 2 times x plus 5 over 2 times x is 10 over 2, if you follow me. Let's make a little more space to make sure we have this. This we can easily do. We can subtract that with no problem. So here we have to, I just want you to see this. So I'll do it right here, then we'll erase it. X plus 5 over 2 times x plus 5 over 2. So x times x is x squared. X times 5 over 2 is 5 over 2x. 5 over 2 times this x will be another 5 over 2 times x. And this times this is 25 over 4. So 5 over 2 plus another 5 over 2 is 10 over 2. If I just add these fractions. And 10 over 2 is 5x. So I'm right back to this. So if you work that out, you can see how it would look. We'll do another one if we have time today. If we don't, we will come back and do it. So I'm going to erase this for right now. So now, once I have this, and I know that it's a perfect square, you could see I could actually write this as follows. I don't have any more board space, so I'm going to have to take one of these out. Since x times 5 over 2 and x times 5 over 2 are the same term, if you can see it, I could eliminate one of those and just say squared. X plus 5 over 2 squared is the perfect square. And so I could take out the other term because it's just a repeat of it. That's what I mean by a perfect square. So now I have x and 5 over 2 becomes my perfect square, and I square it. And that equals, so now I have 25 over 4. So what is 6 if I turn it into fourths? 6, if I make it fourths, would be what? 24 over 4 would be 6. I can just see that. Can you see it? If I change 6 over 1 and I make it into fourths, I'll multiply this by 4, multiply this by 4, and I get 24 over 4. That's the same as 6. So now I have two fractions with the same denominator. So this will be 24 over 4 plus 25 over 4. So what is 24 over 4 and 25 over 4? That's really 1 over 4. I'm sure you can follow that. So now I have this statement, x plus 5 over 2 squared equals 1/4. So I'm going to make this a little bit closer. So now, what would I do next? X plus 5 over 2 squared, if I take the square root of this and take the square root of this, this is where I get my plus or minus. So my two answers are going to come from this square root of this right-hand side. So now let me say this. You know from principle that this factor squared, if I take the square root of it, the square root of it is going to be this factor without that exponent. So it's actually going to be x plus 5 over 2, period. Or I could put 2 of these in there and you can see the square root is going to be one of them. So this may be sounding confusing, but when we get to do a couple more, you'll start to get it clear. So the square root of 16, let's say, the square root of 16, if I take the square root of 16 is 4, but if this was 4 squared, and I took the square root of 4 squared, it's still 4. Because 16 is, the square root of 16 is 4, so the square root of 4 squared is 4. So the square root of any square is going to be the term without the exponent. So when I take the square root of this, I'm going to get x plus 5 over 2. So I'm going to move that over here. X plus 5 over 2 is going to be equal to the square root of 1/4. So what is the square root of 1/4? Here's the first trick you want to see if you can follow me. So when you have the square root of a fraction like this, I'm going to put a little blue. It's not coming out blue. I'll put a little green. The little green is not coming out green either like I want. Okay, this is better. So you take a square root of a fraction and you can always express it as the square root of the numerator and the square root of the denominator. So now you have 2 square roots instead of 1, and most of the time you can function better with it. So I have the square root of 1 over the square root of 4. So I say, well, what is the square root of 1? Well, that's 1. So I have x plus 5 over 2 equals 1. So the square root of 1 is 1. It's a plus or minus 1, but it's 1. Square root of 4 is 2. So now I have 1/2. So I have plus or minus. Because I have plus or minus, I still end up with plus or minus. So now I have this down to something where I could figure out what x is. So I say x plus 5 over 2 equals plus 1/2. That's one result. The other is x plus 5 over 2 equals negative 1/2. So now, I could say, let me work this out and see what happens. I'm hoping I get the same thing I got here, even though we use a different procedure. So if I subtract 5, I get x equals 1/2, take away 5 over 2. In this one I say x equals negative 1/2, take away 5 over 2. So if I have positive 1/2, take away 5 over 2, if you follow this okay, so now I have 2 fractions with common denominators, so I just subtract the numerators and keep the denominators. So this is negative 4 over 2, or negative 2. In this case, I have 2 negatives, so I just add them together and keep the negative sign, so I get negative 6 over 2, which is negative 3. So even though I completed the square, if you follow me, we end up with the same answer, x equals negative 2, x equals negative 3. That's the same thing I had here when I factored. So you have now in your arsenal of ways to deal with quadratic equations, you can factor, because factoring is usually easier because you come to the conclusion faster. If you can't factor, you can complete the square. which involves three steps. Step one, you move the constant c to the other side. Step two, you take 1/2 of the coefficient and square it. Then you have your perfect square. Your perfect square is going to be x plus this squared. And then to keep the equation balanced, which you have to do at all times, if you change one side, you have to change the other side, otherwise the value of the equation is no longer equal. So since I put 5 over 2 squared, I got 25 over 4. I had to add 25 over 4 on this side. So this forced me to put this on the other side. Once I did that, I could see 6 is 24 over 4. Then that left me with 1 over 4. Then I used my technique here to split the 1 square root into 2 square roots. So I have the numerator squared, the square root of the numerator, square root of the denominator. So I had the two options. Now, if we have time, I want to go to the third option, which we can do, but I think I should probably clean off the board. We got 21 minutes on this first tape. So I'll clean off the board and try to do the same problem with the third option, which is the quadratic formula. So let me stop this, clean this off, and then we'll come back to that. Okay, I've taken the liberty to clean things off and to give you the quadratic formula. So if you have a problem, just to review, if you have a quadratic equation, your first thing is to see if you could factor it, because factoring it will get you to the answer, the two possible answers quickest. If not, you can complete the square, which you know means moving the constant c to the other side, take half of the coefficient of the single variable x without the square, and then square that, and that gives you a perfect square. Whatever you take half of b, square it, you'll have to add that amount to the other side to keep it equal. So that's completing the square. Then you just go through the steps to take the square roots, and you end up with two possibilities. The third possibility, which is interesting and it's fun once you figure out how to do it, is most students like it because it seems very complicated at the outset, but when it's figured out, they realize it's fairly simple to do, and they like doing it. So here's how it goes. It relies on the understanding that the basic quadratic expression is ax squared plus bx plus c. So you can see here from what we have that the equation has b, b, a, c, and a. And it has the number 4 and 2 there. But if you can just plug into your formula, quadratic formula, you can just plug it in, you'll get your answers for x. And you can see that x will plus or minus will give you the two options right here. So let's do the same problem we've been doing, where we can see a is 1, b is 5, c is 6. So I'm going to write it back here so it'll give us room to work. So my first thing, x equals negative b. b is 5, so it'll be negative 5. Plus or minus the square root of b squared, b is 5, so that's 25, minus 4 times a and c. Well, 4 times a is 4 times 1, and c is 6. So 4 times 1 is 4, and that 4 times 6 is 24. So I have 4 times 24. over 2a. In this case, a was 1, so it's over 2. So now, I have, let's make sure we have it right. So, minus b plus or minus the square root of 4ac. 4a is 1, and 4 times c is 26 is 24. So let's see. So now we have x equals negative 5 plus or minus the square root of 25 minus 4 times 24. 4 times 4 is 16. 4 times 2 is 8, and 1 is 9. So that's 96. So over 2a, which in our case is 2. So this 2 actually is the denominator here. So we got 2. So now we have a little problem because inside my radical sign, I'm going to have a negative number. So we can't get a square root of a negative number because it's not a real number. So let's see what we do here. The square root, well, we'll just see how this develops. X equals negative 5 plus or minus. Now what if I took these this square root and made 2 square roots out of it, like plus or minus 25, take away square root of 96, I don't know. Well, let me not do that because it might throw us off and get you confused too. So we will see what's going to happen here. Let me clear a little more space. So what is 25 take away 96? So let's do it and see what happens. Minus 5 plus or minus square root of 25 take away 96 is going to be 1 and 7. Negative 71. So the negative 71 is not a real number. So there's nothing I can square, multiply by itself and get a negative. So let me make sure we did the right thing here and I took down the right formula, because if I didn't. Okay, and looking at this, I see what has created a problem. I was a little bit too hasty, so let's go back together and do it so that you'll see the mistake I made and you can see how easy it is to make a mistake. So in the formula, I plugged in minus 5 for b, b squared was 25, then I have 4ac. A is 1 and c is 6, so that's 4 times 1 is 4, and 4 times 6 is 24. So here I kept the 4 times 24 as if that was right. So this 4 made my the subtrahend bigger than the number, so that was wrong. So this is not 4 times 24, it's 4 times 1 is 4, and 4 times 6 is 24. So here's my error right here. So this is really 24. So let me get rid of the 96 and make 24, because this subtraction shouldn't end up negative. So now I'm straight. So I don't have a negative 71, which I can't do anything with that. So I have 25 take away 24 is 1. The square root of 1 is 1 plus or minus. So I have x equals negative 5. Oh, I have plus or minus 1 over 2 though. So my 2 is still there. So let's continue this right here. So now x is going to be equal to minus 5 plus or minus 1. I can get rid of this equation, square root sign. So 5, x will equal negative 5 plus or minus 1 over 2. That makes sense? Negative 5 plus or minus 1 over 2. So if 1 is a positive, I have negative 5 plus 1 is negative 4 over 2, which is negative 2. If negative 5 and 1 is a negative, I have negative 6 over 2, which is negative 3. So using the quadratic formula, I end up with negative 2, negative 3, just like I did when I factored, just like we did when we completed the square, and just like we did once we corrected my error by using the quadratic formula. Now what I may do tomorrow, because I have a Zoom call coming up, and I'm happy to get this into your hands. My Zoom call is at 6 and it's 5:20, so I have time to get back to the village, back to the palace. I'm in the village. But I have time to get back there and set up for the Zoom call. And I'm content now that we have covered quadratic expressions and equations using the factoring method, using the completing the square method, and the quadratic formula method. So that gives you all three of those methods, which I'm sure will be included on the assessment that's coming up. So hopefully you'll get some time in your busy schedule to do some practice. And I will come the next time and review the work with exponents that is likely to be covered as well. So it's not hard, but if you didn't know and it hadn't been introduced to you at all, it would be unfamiliar. That's all it will be. So we'll come back to this and see how you do. So congratulations on your lacrosse game or field hockey or whatever it was. I saw the goal. It was exciting. Bye-bye.